let us develop a basic understanding on jute carding. Firstly, let us understand the need of carding for raw jute fibers. Each raw jute reed has a messy structure of interconnected fibers. But for preparation of yarns, we need individual fibers. Thus, we need to break this messy structure into individual fibers and to open them. For successful spinning of yarns, we also need to produce a more or less uniform linear assembly called sliver of such individual fibers, which can be progressively thinned down to a substantial extent. For this, these individual fibers need to be separate without much entanglement. For breaking of messy structure, for opening of fibers, and for producing a uniform sliver, we need the carding process. Thus, the objectives of jute carding are set as A. To generate individual fibers suitable for spinning by way of longitudinal splitting and transverse breakage of the messy structure of jute reeds. B. To satisfactorily mix the jute fibers of different qualities, that is grades. C. To generate a uniform assembly called slivers of unentangled fibers. The jute carding usually have two operations, namely breaker and finisher carding. Sometimes one more carding operation called intercarding is carried out. Inferior quality jute also needs intercarding operation for making them suitable for spinning. Spinnable fibers are also produced from root cuttings and waste materials by the use of teaser cards, which are of two types, gunny waste teasers and thread waste teasers. At first, we will study the breaker card. First, we will understand the functions of a breaker card. The basic objectives of a breaker card are 1. To break down the messy structure of jute reeds to generate individual fibers suitable for spinning. 2. To satisfactorily mix the jute fibers of different qualities, that is grades. 3. To generate a uniform and unentangled assembly of fibers called slivers. The breaker card is a half circular type card, since only the half portion of its cylinder is used for total carding action within this machine. For this, the feed side and the delivery side of this machine are approximately 180 degrees apart. The breaker card is also a downstriking type card, since in this machine the cylinder pins approach the feed from the top and strike down into the fiber for effecting carding action. Most of the breaker cards have two pairs of workers and strippers, one pair of drawing rollers and one pair of delivery rollers. Let us now understand the carding process as executed by the breaker card and the functions of each of its components. Let us first consider the breaker card having arrangement of feeding of spreader rolls. This is creel, a platform for placement of several spreader rolls at the feed and unwinding them for continuous feeding. Now we are observing that the spreader rolls of different sizes have been kept on the creel. This is the right method for spreader roll feed, what is called staggered feeding. We are observing that different qualities of jute are fed to the breaker card. Now we are observing the fiber flow inside a jute breaker card. We are observing the process of feeding of jute fibers inside the breaker card for subjecting them to carding action. From the feed apron, the jute reeds are drawn through a pair of fluted rollers by the pool of pin feed roller and presented to the cylinder for carding action. The fluted rollers assist in control of feeding of jute fibers and also to stop gulping. The feed roller exerts a controlled pull on the jute reeds and also offers resistance to prevent sudden drawing of the reeds by the cylinder. The sail acts as a base platform for presenting the jute reeds towards cylinder for carding. Jute enters the space between the pin feed roller and the sail and travels towards swiftly moving pins of the cylinder. There are several joints between the fibers within the messy structure of jute reeds, which are to be broken for getting individual filaments. The downwardly moving pins of the fast-moving cylinder strike down into the leading end of the jute reeds held back by the feed roller and the sail, and the reed's messy structure breaks down into individual jute filaments of varying lengths with branches. This is the carding action. By carding action, a fibrous fleece with more shorter fibers and less longer fibers is formed and carried forward by the cylinder pins. The carding action is ideally meant for a longitudinal splitting of the reed's messy structure into long individual fibers without entanglement. But due to very low extensibility of jute fibers, the fibers suffer transverse breakage much more than desirable, generating higher amount of short fibers. This carding action takes place with each jute reed as it encounters the pinned cylinder surface, and more amount of fiber fleece is formed and carried forward with the cylinder. Once again, we are observing the passage of fibers inside a jute breaker card. To accommodate the longer beard, the fast stripper is placed 4 to 5 feet away from the cell. Let us now follow the path of the carded fleece as carried forward by the cylinder from the feed side. It is seen here that a portion of the fiber fleece in a thicker region is being transferred from cylinder to worker, and then worker to stripper, and finally back to cylinder, maybe in a region of thinner fiber fleece. This is how the fiber fleece becomes more and more uniform during its passage towards the delivery. At the same time, a secondary carding action is taking place in this region, resulting in further splitting of jute fibers. Carding ratio is equal to cylinder surface speed divided by worker surface speed. The normal range for carding ratio is 45 to 55. By such actions of workers and strippers, the mixing of different qualities of fibers is also taking place. For achieving good regularity and good mixing and also better splitting of fibers, more than one pairs of worker and stripper rollers have been provided in the cards. The backward facing pins of worker having slower speed as compared to fast moving cylinder collect a part of the fiber fleece from cylinder and allow the rest to be carried on by the cylinder. Again, the stripper, due to its direction of pins, and higher speed collects a part of the fiber fleece from the worker and allows the rest to remain with the worker. The fibers are then transferred to the cylinder from stripper for the same reason. Below the worker, there is a rotating cylinder called tin cylinder, which resists the droppage of long fibers during the action of worker and helps them to pass on the stripper, but allows the short fibers to drop. It is seen here that after having similar transfer cycle through the second pair of worker and stripper, the fiber fleece meets the doffer, whose function is to strip the jute fleece off the cylinder and pass it to the nip of the drawing rollers for final delivery from the machine. Doffer's action is similar to that of the worker. Ideally, doffer should take away the entire fiber fleece out of the cylinder, but practically it does not happen so. Some fibers always evade the doffer action and travel round the cylinder for several times. Then the fiber fleece is caught as a thin wave in the nip of the drawing rollers and doffer pins. Drawing rollers have nearly twice the speed of the doffer. The wave emerges from the drawing roller nip and passes down along a V-shaped metal sheet called conductor, having a mouth opening which consolidates the thin fiber wave into a ribbon-like fibrous assembly called sliver. Then the sliver is drawn through a pair of delivery rollers whose top roller is quite heavy to compress the fibrous assembly into a thick, compact sliver ribbon. Finally, with the help of an attachment called roll former, the delivered sliver ribbon is converted into a coreless compact roll. The sliver is got delivered as a roll so that the card sliver roll can easily be transported to the next machine for further processing operation, and the auto doffing mechanism of the roll former helps to deliver all such rolls with same diameter. The different parts of the roll former are shown. We are observing the movement of the cam and disc opening rod and block for effecting the auto ejection of the rolls. There is a pump for creating pressure so that the rolls become compact. Now, let us see once again the breaker card operation with feed of spreader rolls. Let us now see the common wrong practices of the workers during breaker card operation. Due to improper feed, a gap is created in the feed on the apron. For this, a thin fiber fleece is seen coming out, causing more irregularity in the delivered sliver. Such feeding practice, called rainbow feeding, is very common with the workers. Such overlapping feed is also not very uncommon. For the faulty rainbow or overlapped feeding, a thick fiber fleece is seen coming out, which will increase the sliver irregularity. This is the right method of feeding. Let us now see how the long jute reeds are fed to the breaker card. The hard barky root ends are cut out from the reeds. We are observing the right way to place the cut long jute reeds on the feed apron of the breaker card. This is staggered feeding. The long reeds should not be fed in this manner. Due to wrong feeding, gulping of reeds is taking place, by which reeds become entangled within a small length, which increases the sliver irregularity. The improperly carded fiber fleece is coming out. In case of observance of improper carding by the breaker card, the supervisors should check the followings at the earliest. 1. Condition of pins. 2. Gauging of the rollers. 3. Condition of the cell. 4. Condition of feed roller. 5. Draft amount. The delivery rollers may be jammed when a very thick portion of the sliver is drawn. For this, a good amount of fiber fleece may be wasted. To avoid such jamming, the feed should be regular and moisture in the fibers should not be higher. Due to high moisture in the fiber, there can be lapping of fiber fleece at the drawing rollers, for which the machine has to be stopped for cleaning purpose. The basic information is desired to be displayed on each breaker card. In comparison to wooden staves, metallag exhibits better performance in terms of 1. Higher speed, 2. Improved carding action, 3. Easier restaving, and 4. Longer life, but is found unsuitable for fibers with higher moisture, that is more than 35% moisture again. Let us now understand the functions of a finisher card. The basic objectives of a finisher card are: 1. To execute a finer carding on the breaker or intercard sliver to make the filaments more suitable for spinning. 2. To execute a further cleaning action for the filaments. 3. To make the card sliver reasonably uniform for the efficient operation of the subsequent drawing operations. 4. To mix more intimately the different qualities of jute fibers. The finisher card may be half circular or full circular type card. In the full circular card, almost the entire portion of its cylinder is used for total carding action. For this, the feed side and the delivery side of this machine are situated nearly side by side. The finisher cards may have pairs of rollers varying from 3.5 to 5.5. A finisher card has more number of workers and strippers as compared to those in breaker card. Higher density of finer pins and more number of pairs of worker and stripper rollers in the finisher card help to produce the final card sliver with good quality by effecting actions for further splitting and cleaning of carded fiber fleece, for more intimate mixing of different fiber qualities, and for improved regularity along the length of the card sliver. At the feed of the finisher card, there is a pin roller called feed stripper, which prevents lapping of fiber fleece on the feed roller and also assists the fiber fleece to move towards the cylinder. The finisher card may have single or double doffers to deliver fiber fleece from one or two outlets, and then the condensed fleeces are mixed together and sent to the roll former directly or through an apron in the sidewise or backside of the card. The finisher card sliver is seen delivered in roll form. There are selvage plates on both sides of the drawing roller. These plates help to deliver a uniform fiber fleece and also prevent jamming at the drawing roller. Please note the improper delivery of fleece due to absence of selvage plate. The belt drive system for moving the cylinder strippers is shown here. The gearing arrangement is shown here. Different rollers like feed, workers, doffer, etc. are driven by the cylinder. The basic information is desired to be displayed on each finisher card. Now we will pass on to intercard. This additional processing stage of intercarding is needed in case of inferior quality of jute for having further splitting and opening of filaments to make them suitable for finisher card. We are observing the working of an intercard. Mostly the half circular finisher card is used as intercard. Let us now understand the use of teaser cards. During processing in a jute mill, there is always generation of different waste materials. For converting such wastes to spinnable fibers, teaser cards are used. There are two different types of teaser cards. One, thread waste teaser for preparing spinnable fibers from waste yarns and ropes. Two, gunny waste teaser for preparing spinnable fibers from gunny bag wastes. Let us now move on to see the processing of waste materials by the use of teaser card. Wastes are fed to the teaser card. Fleece of teased filaments are coming out. Waste ropes are cut and fed to the teaser card. Fleece of carded filaments are coming out. Such fleeces are converted to roll forms by using teaser breaker cards. In the jute mills, different types of yarns are produced, and depending upon the type of yarn and batch mix selected judiciously for that yarn type, the carding operations need to vary for ensuring the quality as well as the spinning efficiency for that particular type of yarn. For producing good quality yarns like Hessian warp and export yarn by using good fiber batch mix, usually 2 carding operations are employed, starting with breaker card and followed by finisher card. For producing medium quality yarns like Hessian weft and sacking warp using moderate fiber batch mix, usually 3 carding operations are employed, starting with breaker card, followed by intercard, and lastly with finisher card. For producing inferior quality sacking weft, substantial amount of waste materials is used along with long jute. For producing sliver rolls from waste materials, teaser and teaser breaker cards are employed, while for long jute carding, breaker cards are used. At intercard stage, teaser rolls along with breaker card rolls are fed and intercard rolls are finally carded in the finisher cards. Picking and cleaning. Now we are observing cleaning of doffer roller of a finisher card on running condition of the machine. The picker, with the help of a strong broomstick, cleans the adhering fibers from the doffer pin. He also cleans the drawing and drawing pressing rollers, tin conductor and its mouth. He cleans the arbor of rollers and shrouding of the card. He cleans and checks the selvage plate. Now we are observing the cleaning and picking of workers and steepers after stopping the machine. The worker wheel is dismantled to allow the worker roller to rotate freely. After raising the cover, picking and cleaning are carried out. We see 2 pickers are picking and cleaning the worker rollers. We see that the waste and dust accumulated on the shrouding are being cleaned by the pickers. We are observing now the cleaning of cylinder. We see picking and cleaning of stripper after disengaging the stripper driving belt. We are observing the cleaning of carries and droppings from the underneath of the card. From this, the usable fibers are separated manually. Dust is sent to the boiler for burning. Let us now observe the method of card gauging of rollers with gauge plate. We are observing the process of oiling of arbor of rollers by oil can and refixing of wheels. We now see the standard brass gauge plate with gauge number punched on it. We see the selvage plate of the card. We see the different shapes of cards with pins. We are observing a table showing the pin angles for different rollers of both breaker and finisher cards. Moisture level in jute fiber or sliver should be as per standard. Excessive droppings under the cards should be avoided. Toffer cleaning and card picking should be carried out at regular interval. No missing roll should be allowed at the feed of the cards. Right performance by the workers should be ensured. Broken and bent pins on card rollers should be replaced at a regular interval. Soft or hard roll formation should be avoided. Rolls should be used at a quick interval to ensure best use of moisture present in them. Jam at the drawing rollers should be attended immediately. Roll former should be maintained properly to avail good efficiency from the cards.